there is no single way that all scientists use to make some scientific investigations. One scientist may use his own way, the other one may use another way. So we cannot have one way to make a scientific research. There is no single way by which scientists follow to make some kind of investigations or to make some research. But scientists, scientists put as a guideline that allow them to make some kind of investigations. These are like the ways or kind of rules, you can call them rules, by which all scientists commonly use. The first step they have to do is they have to make careful observation on what they are doing. The first step in any scientific investigation is making a careful observation on what they are going to do. So to make any kind of good scientific investigation, the scientist has to follow these steps. The first step is making careful observation. We have to observe. The first step is what? Observation. We have to carefully look at. When we say observation, we mean that carefully, we have to carefully look at what we are going to do. Once we carefully look at and collect data from what we are investigating, the next step will be we formulate a theory, or we formulate a hypothesis. Formulate and objectively test the hypothesis. We test it. But how are we going to test it? We test our data, the data that we collect. In our first step, we have to check and hypothesize by making an experiment. We have to make a hypothesis, or we have to test our hypothesis by making an experiment. So the second step is testing the hypothesis by making an experiment. We can't make a hypothesis just simply as it is. We have to prove it by an experiment. But what's the meaning of hypothesis? Let's see what's the meaning of hypothesis. Hypothesis is an explanation that is based on prior scientific research or observation that can be tested. This is very important. So it's like, our experiment, the data that we collect has to be hypothesized. We have to carefully explain based on the research, based on the observation. So hypothesis is what? Carefully explain. Based on the prior research, the previous research. The third step is we collect data in the first step. We collect data. Then the data that we collect, we prove it by an experiment. Then we interpret, we collect data, we hypothesize, and we just make the experiment and put it in a table form. After that, after we make an experiment, we interpret the result. Here what we have to do is we interpret the result. Interpreting the result that we get by an experiment. We interpret. So we collect data. The data that we collect has to be proved by an experiment, and the experiment that you are making has to be put in a table form. And finally, once we put in a table form, we interpret. We give it careful interpretation, or we revise the hypothesis here. If it's not the way we expect, we can revise our hypothesis. Finally, once we interpret, we revise. If we think that it is correct, we arrive at a final step. That step is called conclusion, or we set a law. So after going through these all steps, finally we'll arrive at a conclusion that can be evaluated by other scientists. When you say conclusion, it is something that can be tested or evaluated by others. It will be checked down or evaluated by other researchers or scientists. As I told you before, hypothesis is like an explanation that is based on the prior research. Here what you have to do is, when scientists are making a research or making an experiment, they have to use a model. When they are making an experiment, they have to use a model. And what's the meaning of model? A model is a plot or a pattern or a plane or a representation or a description that is designed to show the structure or working of an object. How does it works? It tells us a model is a representation that shows us how a given object or how a given model works. How it shows how it works. What are the materials inside? What are the necessary things that we need to make the model? So that's a model. So generally, models help us guide our experimental design. If you want to make an experiment, we have to start is by preparing a model. So it is like a guideline. It helps us a guide for our experimental design, for the design that we are going to put. Or models can help build a hypothesis. To make a hypothesis, we have to prepare a model. So from the model that we prepare, we can build up a hypothesis. We can prepare or build up or set up a hypothesis. And the other thing that we have to is the meaning of system. What is a meaning of what? The meaning of system. What's a system? A system is a set of particles or interacting components considered to be distinct physical entities. Separate. Distinct means separate. For the purpose of our study. So, for the purpose of what we are going to do, we need to have a system or a set of interacting particles. Or components. So, like, we prepare a system, we have a model, now we are going to make an experiment. And that kind of experiment is called controlled experiment. What's the meaning of controlled experiment? What's a controlled experiment? A controlled experiment is an experiment that tests only one factor at a time. See, in this case, we can't test many factors at a time. We just test one factor at a time. Because we are controlling. A controlled experiment is an experiment that tests one factor at a time by using a comparison of the control groups with an experimental group. The next part is section 2. We are done with section 1. Next one is section 2. That is measurements in an experiment. Like when we are making an experiment, we have measurements. Like we may be asked to measure the length of an object, the volume of an object, the area of a given space. So how do you measure in an experiment? What do you use to make an experiment? So the description of what kind of physical quantity is represented. Is it by a certain measurement? It's called dimension. So you should know the meaning of dimension. A dimension is a description that helps us to define what kind of physical quantity is represented. And there are three basic dimensions. This is very important. We have three basic dimensions. Basic. I'm not saying there are only three. We have three basic dimensions. These are length. First dimension is length, which is symbolized by capital letter A. Next is mass. And time. This is T. So these are the three basic dimensions. Sometimes we can use, by the way, these are the three, but we can also add temperature and current. When there is heat and electricity. But the three basic dimensions are mass, length, time, and sometimes temperature and current. For example, you may be given a physical quantity, and you may be asked to express the given physical quantity in the dimension form. What are the dimensional? For example, write the dimensions of speed. For example, speed. To find the dimension of speed, we start with the definition of speed. What is the meaning of speed? A speed is defined as the rate of distance traveled. That is, distance divided by time taken to cover that distance. Symbolically, I can use a speed V is a symbol for speed, which is the same as the distance is S. Sometimes I can use L, because the distance between 2 points is the same as the path length between these two, or the state length. The distance from A to B is this state path. So distance S is the same as I can use L. So the dimensions of speed are L divided by T. This is the dimension of speed. Let me give you another example. What are the dimensions of example 2? What is the dimension of acceleration? So to find the dimension of acceleration, we have to start with the meaning of acceleration. We know that acceleration is defined as the rate of change of velocity. So to find the dimension of acceleration, I have to use the dimension of velocity and the dimension of time. We already know that the dimension of velocity is already calculated. I have already shown you in the above example, which is L divided by T, time, over T is capital letter T. Now we have to simplify this ratio. which is equivalent to, I can rewrite this as L divided by T divided by T. I can write this as T over 1. So this is equivalent to L over T. Whenever we are changing this division to multiplication, I will reciprocate the second expression, that is 1 over T. So this is equivalent to, I can write this as L multiplied by 1. I will multiply the numerators together and denominators together. That will be L times 1 is L divided by T multiplied by T is T square. This is the same as in some books, or you can rewrite this as L T minus 2. This is the dimension of acceleration. That's all how to find. This is a way how to find the dimension of a given physical quantity. You can add, if you like, you can find the dimension of force, work, power. So this is a way how to calculate the dimension of a given physical quantity. Next to this is, what are the two types of physical quantities? In our previous lesson, we defined what a physical quantity means. Physical quantities are quantities that can be measured and expressed in number. We can measure them. After we measure, we express by a number and a unit. So physical quantities are quantities that can be measured and expressed in number. And we have two types of physical quantities. One is basic physical quantity. The other one is derived physical quantity. So why do you call them basic? Basic quantities are quantities that can be measured directly. We can measure them directly. And the best examples of basic physical quantities are, by the way, the basic physical quantities are 7 in number. The basic ones are mass, length, time, current, electric current, temperature, amount of a substance, and luminous intensity. These are the 7 basic physical quantities. The remaining other quantities are derived physical quantities. We call them basic because the remaining other quantities are expressed as the product or quotient of these 7 physical quantities. Product or quotient of these 7 physical quantities. That's why we call them basic physical quantities. The second type of physical quantities are derived physical quantities. These are quantities that cannot be measured directly. We can't measure them directly. We measure them indirectly by calculating the basic physical quantities. And examples of derived physical quantities are speed, acceleration, force, work, power, etc. So these are the two basic physical quantities that we have. One is basic, the second one is derived.